In this lesson, we will examine the artificial feel systems used by powered flying controls, and then we will look at some of the safety and backup systems built into powered flying control systems. When fully powered flying controls are operated, there is no aerodynamic stick force fed back to the pilot. He therefore has no feel for the aerodynamic effect his control movements are having, meaning that there is a danger of him over-controlling the aircraft or of overstressing the airframe. To prevent this problem, and to ensure that the control center when the pilot's control input is removed, artificial feel units are fitted in parallel with the powered flying control units, or PFCUs. The simplest feel unit consists of a box containing two springs, known as a spring box. Movement of the control column in either direction will compress one of the two springs. While this will give the pilot feel and will center the controls when the control input is removed, the feel will not be proportional to the air loads. It will be the same over the entire speed range. Most modern aircraft have feel units fitted with devices known as Q-pots. These devices measure dynamic pressure in the same way that an airspeed indicator does. Q is the commonly used abbreviation for dynamic pressure. In the system shown here, static air pressure is felt on one side of a piston, with pitot pressure on the other. The piston, therefore, is feeling the difference between pitot and static pressure. The force pushing the piston to the right will therefore be proportional to airspeed, and thus proportional to the aerodynamic force being felt at the control surface. When the pilot makes a control input in either direction, the bell crank linkage to the Q-pot means that he has to overcome the dynamic pressure in order to operate the PFCU. Whilst the feel produced by a Q-pot is proportionally correct, its magnitude is quite small. To produce feel of a significant magnitude, the Q-pot would have to be very large. So Q-pots are normally used to control hydraulic pressure, which is used to amplify the feel up to a usable level. In the schematic shown here, the Q-pot controls the position of a hydraulic spool valve. The pressure gauge is not part of the system. It is shown only for illustrative purposes. The pilot's flight control input is connected to a hydraulic piston. He has to overcome the hydraulic pressure being applied to the piston in order to operate the control. With the forward movement of the aircraft, pitot pressure is fed to the upper chamber of the Q-pot section of the unit, pushing down the diaphragm. The diaphragm is connected to a spool-type selector valve, so that the downward movement of the diaphragm opens the hydraulic pressure port and partially closes off the return port. Hydraulic fluid emitted to the unit will then pass to the forward side of the piston. The fluid also passes through a narrow channel to the underside of the spool valve to dampen its downward movement. As the airspeed increases, the pitot pressure will increase, pushing down on the diaphragm, increasing the size of the opening of the pressure port in the selector, which means that the pressure in front of the piston will increase, thereby increasing the resistance to control movement. The return port is never fully closed, as this would cause a hydraulic lock to form in the system. The Q-pot artificial feel system gives increased feel with increasing airspeed. However, when the aircraft is stationary or moving slowly, it produces very little feel or control centering. Some systems combine the spring box and Q-feel systems. The spring produces the majority of the feel and centering when the speed is low. In the system shown here, the spring and the hydraulic piston both operate against a cam. This increases the feel effect with increasing control input deflection and produces a positive centering force at all speeds. Having artificially produced the feel, there are going to be times when the control needs to be other than central. The rudder, for instance, will need to be held displaced in the event of engine failure on a multi-engine aircraft, or the yoke will have to be held back in a climb. Each of the three primary controls has a feel trim system which allows the feel to be reset to 0 with the control away from neutral. Shown here is a rudder feel and trim unit. When the pilot makes a rudder input, the cam compresses the spring, thus providing feel. In the event of an engine failure, the pilot will have to hold the rudder away from the centre, and this will be opposed by the spring pressure. In order to relieve the load, he rotates the trim wheel. This will move the spring around its hinge point until it is acting through the centre of the cam, allowing the pilot to fly feet off. Safeguards to eliminate the possibility of loss of control in the event of hydraulic or mechanical failure must be provided on modern transport aircraft. This is generally achieved by building redundancy into the control system. Mechanical failure in the form of a jam in the control run is safeguarded against by having two sets of control cables running to the PFCU, one set controlled by the captain and the other by the first officer. The control columns are linked together so that movement of either control normally operates both cable runs together. In the event of a jam in either system, the coupling device can be opened either by pulling a handle in the cockpit or by applying excessive force to the controls. This will allow the pilot with the free control run to operate the flying control. Having more than one actuator, each of which is powered by a different hydraulic system, will allow the flight controls to be operated in the event of hydraulic failure. In this lesson, you have seen that fully powered flight control systems require an artificial feel system fitted in parallel with the controls, and that this is normally supplied by a hydraulically powered Q-pot. You also now know that both mechanical and hydraulic redundancy is built into the fully powered flying control systems of all large airliners.